All right, let's talk about a powerful but often misunderstood tool in Go, syncMap.
So let's start with a mystery. You add more hardware to your server, but it actually gets slower. How?
Well, that's exactly what happened to a developer named Ethan after a big 32-core server upgrade.
His performance profile pointed to a surprising bottleneck, the lock he used to protect a standard map.
This is called lock contention. See, even a simple read lock creates a massive traffic jam in memory.
So how do you fix this? At this scale, you need a specialized tool from the standard library, sync.map.
Okay, so how's it different? A sync.map locks itself, so you can't use the usual square brackets anymore.
You have to use its methods instead. And since it's older than generics, you need to assert the type.
So sync.map solves the lock problem. But what about the other race condition hiding in your cache?
It's called a cache stampede, and it can totally overwhelm your database when a popular item expires.
Just imagine hundreds of requests all miss the cache at once, and they all slam the database together.
And this is where sync.map has a superpower. It's a special atomic method called load or store.
This makes sure that only one of those requests actually hits the database to fill the cache. Just one.
Seeing this, you might be thinking, wow, I'm going to replace every map with a sync.map.
But hold on, that's actually the biggest mistake you can make with this tool. Seriously.
Here's the key thing to remember. Sync.map is not a universal upgrade. A normal map is usually faster.
So that begs the question, right? If it's not a general-purpose tool, when should you actually use it?
The answer's simple. It's heavily optimized for only two very specific scenarios.
Number 1, for append-only caches, and 2, when different Go routines are working on totally different keys.
If you don't fit those patterns, sync.map gets super slow, way slower than a simple mutex.
And that's really the big takeaway. Knowing the tool is one thing. Knowing its limits, that's everything.